Hello friends, welcome to B.Tech. So in this video I am going to explain about the specialized process models. So these specialized models will be applied when the project, that means when the requirements are narrowly defined, so then you are going to use these particular specialized process models. So you have three types of models that are listed here. The first one is component based development, and the second one is formal methods model, and the third one is aspect oriented software development. In short, you can call this as AOSD, aspect oriented software development. So these models will be used when the requirements are narrowly defined, that means complete description about the project is not completely defined. So then in this case we can follow these three models to design a software. Initially, we are going to see about the component based development. So in the component based development, see the first point. So component based development is an approach to software development that will be focusing on the design and development of reusable components. So mainly the purpose of this particular component based development is, so we are going to reuse the components whatever earlier we have done already in the project. So it mainly focuses on reusable components, and so by breaking up software into components is the right thing to do. So no one can argue that it's what agile evolution is all about. So what exactly you are doing in this model is you are simply breaking the software into a small number of components. So that means it is already developed one, you are breaking that into a small number of components, and then you are using these components for better business development activities. That means it is going to serve the business needs in a very rapid way. That means you are going to, whenever you are going to complete the product in a very less time, you can use these components, so that will be very helpful for the development. And third point, if you see, so component based architecture stays up to date, so without rebuilding it from the scratch. So why? Because we are dividing the software into different components, right? So why? Because whenever this component is required at some point of time in the other project, so you can directly access that particular component and you can use it there. So instead of starting from the scratch, so you can use that particular feature in the any other new project. And so using these components turns a monolith into software building blocks, and these components can be combined, reused and re-versionized. So these type of components can be combined and reused and versionized, so it can be used for any kind of purposes in the software. And the next one in this one is the formal methods model. So the formal methods model so mainly encompasses a set of activities that leads to formal mathematical specification of computer software. So mainly this formal method model will be used for mathematical specification of a computer software. So that means, so these formal methods enable you to specify, develop and verify a computer based system by applying rigorous mathematical notations. By using the rigorous mathematical notations, you can enable, so how is the project is going on, so that kind of measurements will be applied by using these mathematical notations. Okay, and now so a variation on this approach, it's called a clean room software engineering. So this kind of behavior if you use in the project, in the software project, so this kind of thing we can call it as clean room software engineering, and is currently applied by some software development organizations, not all the organizations. So why these formal methods are not used by all the software organizations are, the methods are during development. So when formal methods are used during development, so they provide a mechanism for eliminating many of the problems that are difficult to overcome using the software engineer paradigms. That means, so when you are developing a normal software project, so you will be facing different problems. So what are these problems? Let's see here. So ambiguity, incompleteness, inconsistency, so can be discovered and corrected more easily, not through ad hoc review but through the application of mathematical analysis. So mainly these formal methods, so it is going to verify the verification, and also there where it will be going to enable you to discover and correct the errors that are might otherwise go undetected. That means, so when you use this particular method in your software development process, so what are the undetected errors that are there in the project, so those will be detected in the earlier stage. So if these formal methods can demonstrate software correctness, so why is this not widely used? So that is the biggest question. So these formal methods are going to correct the project very accurately, and why these methods are not used in the project development, right? So these formal methods offers defect free software, at we have to concern about the applicability in a business environment. So that means, if you see the point here, the development of formal models is currently quite time consuming and expensive. So that is the reason, so not every organization is using this kind of formal method approach. And also, so because a few software developers have the necessary background to apply formal methods, extensive training is required. So very few software developers know about this kind of feature, and if you want to implement this kind of feature in your software process, and you need a extensive training about it, and also it required very extraordinary people to organize the software. Why? Because so it mainly deals with the mathematical problems, and also it is difficult to use models as a communication mechanism for technically unsophisticated customers. So it will not be suitable for the customers who are not technically sophisticated and they are not aware of the technological advancements. So that is why it is not getting that much of popularity. And where we can use this kind of formal methods? Why? Because it is giving accurate results, right? Now, so these formal methods approach has gained main supporter among software developers who must build safety critical systems. So who are building this kind of safety critical systems, so those can use this kind of formal methods. And also examples for this particular one is, so developers of aircraft, avionics and medical devices. So these required accurate results. Why? Because so if anything goes wrong, it leads to total damage. So that is why in these cases, so when some persons are developing these kind of softwares in the organization, so they have to implement this formal methods approach. And also among developers that would suffer severe economic hardship, so that would be errors occur. So if any kind of errors occur in this kind of software development, so that will be very much disaster in the organization. The next one is aspect oriented software development. So and where we can use this aspect oriented software development, see here, so this kind of development is a software development, so that it seeks a new modularization of software system. So that means, so generally what exactly we are doing in the project development or any software process is, so we have to gather the requirements or in the communication phase from the customer, and then we are going to analyze those requirements, and finally we are going to design a design document for those requirements. After that you are going to develop the requirements, and then you are going to test those requirements. So that is the actual plan. So when you prepare a plan for this software, so after that you have to divide that plan into different modules. So these modules will be assigned to each and every software developer, and then at the actual development will be started. So this kind of behavior has some problems. So why? Because so when you divide these development into different modules, so if you want to add any other new functionalities, so where you can add and how you can divide this, so this is the biggest question. So that is why so this aspect oriented software development is designed to avoid that kind of problem. So this uses a new kind of modularization process, and so it is going to allow a multiple concerns to be expressed separately and automatically unified into working systems. And traditional software development and how it is focused on. So as I said, so it mainly focuses on the one particular life cycle, and it is going to divide these modules into different modules, and then you are going to start the coding. So when such thing is happening, so new functionalities we have to add. So at that point of time, so we cannot add in that situation, and we cannot further move into the development. So that is why so we can use this aspect oriented software development method. So see this, the second point. So the traditional development processes leaves it to programmers code modules corresponding to primary functionality, and to make sure that all other issues concerned are addressed in the code wherever appropriate. So that means so whenever a traditional development process leaves some kind of programmatic issues to the developer, so they have to address all these appropriate issues. Okay, so that is about this traditional approach.